Okay, so given you x is continuous random variable with probability density function, this is your small f here, f kecil here. So whenever we do continuous random variable, we start with drawing interval first. So your interval involving here is 0 until 2. 0 until 2 for 1 over 8x. Then 2 until 4 for 3 over 8. So this is your probability, or in other words, this is your graph, and this is your probability, your area under the graph is here. So for the first part, you're going to find cumulative distribution function, means you need to accumulate your probability here. So you will start accumulate from the first interval here, which is before 0. So that will be your first step. Continue, then you accumulate here, second interval, then accumulate to the third interval, lastly to the fourth interval. So you are having 4 steps here. Alright, so how to do F versa cumulative distribution function? So you're having 4 steps for the first step. For the first step, there will be at here, which is your interval before 0, means your x is less than 0. Alright, because this is second interval here, it will be 0 until 2, means before 0, not including. So for cumulative distribution function, we will take the probability before that plus current interval and find your current interval probability. Find your probability means find your area. Alright, so when you have this interval, do you have any probability before that? Do you have any graph before that? Do you have any area before that? We don't have. So before that is 0. Currently, do we have any graph here? Any area here? So not yet. Still don't have yet. So will be currently also 0. So our cumulative distribution function will start with 0. Alright, then we move on for second interval, second step. So when you come to second step, which is interval in between 0 until 2, so this is the interval you will follow, which is equal to 0, not equals to 2. So to find your cumulative distribution function, we want to see before plus current interval. So now you're at here. Means you already finished your first interval, now you're at here. When you're at here, so just look back the interval before this. In the first interval, do you have any probability? No. So before this, we don't have any probability. So for before interval, we get 0. Currently, when you're currently at this interval, you have your graph here, right? So means your area under the graph will be represented by your probability. Means we have some probability at here. So we will start accumulate our probability in this interval. Start from 0 up to not yet 2. If you 2 means you already finished this interval. Okay, so we will start from 0. Of course, we start from 0 because we already passed over the 0, but we not yet reach until random variable 2. Alright, so we will put an unknown here. So it will start from 0 up to x or up to t. So if you don't want to make you confused, you can put any alphabet up to t. Means for current interval here, up to t. For the graph, which is 1 over x dx. You want to put any alphabet here, it's okay. Alright, so I follow the notes here. They will put in the term of t. So they will put in the words in term of t. Alright, so integrate this. Integrate 1 over 8x, it will be power plus 1 over new power, upper limit t, lower limit 0. Okay? So when you substitute upper limit, it will be t squared over 16 minus lower boundary, which is 0. So t squared over 16. But our function is in terms of x. So our function is in terms of x. If you write like this, it will be a bit confusing. Alright, so it will be a bit confusing. So it will be better we will write it as x. So that's why I will put here x. So I'll put here x. I will put it x. So I will integrate it 0 until x. So when I substitute x into x squared, it will still remaining x squared minus 0. Or another word, if you want to use in terms of t, means you will integrate 0 in terms of t, and then your function all in terms of t. To come back with the unknown x, sitting here still x, but your function you change it until t. Alright, so I just remain it same only. So I will remain it as x. So this one t dt. So that you didn't confuse this is x and x. So the process will be same, will be t squared over 16, upper limit x, lower limit 0. So it will be x squared over 16. So your function still in terms of x. Alright? Alright, so just depends on if you hear 1 over 8t, you will be respect to t. If you 1 over 8x, you will be respect to x. And then our upper limit is not 2. If you 2 means you already finished that interval, it's not in the current interval, you already finished that interval. So currently you at this interval, so we have our random variable x here. So we will 0 up to any x here. Alright, then after we finish this interval, we proceed. So we'll come to this interval, step 3, the third interval. So your third interval will be start from 2 until 4. Okay, so when you add this interval, so you look back your random variable here, your continuous random variable here, how much of your random variable already accumulate up to this interval? You already accumulate up to value of 2. So before this, you already accumulate random variable as much as x until 2. So currently you are on 2 to 4. So currently you will get the interval from 2 to 4, but 4 we haven't reached. We haven't come to the end of the interval. So we're still in the middle of this interval. We're still in the current interval. So we will integrate until 2 until any number here. So any number here means any random variable here. It will be 2 until x. For that current interval, for that function is 3 over 8. So before that, F2, then you have to refer to the answer before that, the accumulation here. So accumulation here, maximum you can reach until 2 means you substitute 2 into your cumulative function here, it will be 2 squared over 16. So currently you still have your probability to go on. So you need to integrate 3 over 8 to find the area, to find the probability. So integrate 3 over 8 x, upper limit x, lower limit 2. So this is 1 over 4 here. Substitute upper limit minus lower limit. How much the constant here? 1 over 4 minus 6 over 8. Negative 1. Negative 1 over 2. Is it? Okay, negative 1 over 2. So after you finish that, then we move on to the next interval. So means you come to this interval. So along this, we already accumulate up to 4. For current interval, we don't have any graph, we don't have any probability. Alright, so for this interval, it will be more than 4. So this is not equal, means this interval will be equal. So for number 4, x more than equal 4. Before that, we accumulate up to 4. Currently, don't have any graph, don't have any probability to find, don't have any area to find. So we are going to substitute 4 into the before interval. The accumulation here will be 3 times 4 over 8 minus 1 over 2. One. Is it 1? Yes, you must get 1. You didn't get 1, then finish everything, because what? After you accumulate all the probability, maximum probability until you can get maximum 1. So we accumulate until the end of the interval already. So for sure we must get 1. If you didn't get 1, means something wrong in the working already. Alright. If you more than 1, also something wrong already, because probability how come can maximum more than 1? Alright. Done. Okay, so this is just a working, so we need to write it in function. So we need to write in your result. Starting from the result, starting from the first step, which is 0 for x less than 0. Second result, x squared over 16 for this interval. And third result, 3 over 8x minus 1 over 2 for 2 until 4. Lastly, 1 for x more than equal 4. Okay, then we go for the second question. Ask you to sketch out this cumulative distribution function. So sketch this big F here. Do the drawing for this big F. So how to draw this? We will draw it by piecewise, one piece one. This is one interval, one piece. This is another interval, another piece. This is third interval, another piece. This is the fourth interval, another piece. So piecewise. Satu part, satu part, satu part. Okay? Alright, so for question B, we can start with calculate with its coordinate. So your y-axis will be your cumulative function. So x-axis will be your random variable. Start with 0, you have 2, 4, no more. 2, 4, no more. Maximum 4, right? Okay, less than 0 is 0. How to draw this? Less than 0 is 0. So this is the interval. Less than 0 is 0. Then when you come to second interval, where 0 until 2, you have to find out what is your starting point for this graph, what is your ending point for this graph. So when x equals to 0, what's your starting point? When x equals to 0, what's your y? 0. Ending point, when x equals to 2, this graph, how far it can reach? 4 square, so it will be 1 over 4. So this is our second graph. Means it will start from 0 up to 1 over 4. So here will be 2 over 4, 3 over 4, then 1 maximum. Alright, so for the first point, which is equals to 0, means this is your 10 circle. But for your ending point, when x equals to 2, we have no equal here, means this one will be not included, it will be empty circle. Alright, so how to join these 2 points? How to join these 2 points? It will be the graph of quadratic. So the shape of the quadratic is parabola, concave upward. Parabola, concave upward. Alright, so only this piece only. We need to draw 0 until 2 only. Then after that, for the third piece here, when x equals to 2, we substitute what is your starting point. When x equals to 2, what's your coordinate? You put here 1 over 4. So they are joining. Then when x equals to 4, your last point, what's your y? 1. Not equal. Just now the point is not equal, but now it's equal, so it becomes continuous already. Right? Just now not equal. But for the second piece, it is equal back. So this point is continuous already. So from this point, starting point and ending point, your graph is a linear graph. So how to join these 2 points? By using straight line. Then lastly, more than 4, it will be a constant graph, 1. More than equal 4, so constant graph 1. So this is our cumulative distribution function. Alright, then continue for the part C, what they want. They are asking your probability 1 until 2. Probability 1 until 2. So by using cumulative distribution function, how to find the probability? We need to accumulate the maximum we can, which is up to 2, minus minimum up to 1. Then only you can get in between 1 and 2. Alright, the random variable you want is between 1 and 2. So when using cumulative, once you say F2, means it already collect everything up to 2. Then we need to minus the value before 1 that we don't want. So therefore we minus F1. So F2, 2 substitute at which formula? 2 will be substituted in this formula because 2 is included here. F1, it will fall on this interval. So substitute 2 minus F1, 1 square over 16. So find out your probability. Again, 3 over 16. Is it? Is it? Yes. Okay. Then next, how to find median? How to find median? As we know, if we want to find median, we will accumulate until the median value we can get probability half, which is 0.5. Probability maximum 1, right? So when you want to reach median means your probability only at until 0.5. So what is the median value here? Here we have two intervals to choose. So you have to see this one maximum. For the first interval 0 means we don't have any probability yet. But for the second interval, this interval reach until 0.5 already? In this interval, maximum value is 2. What is your F2 here? 2 squared over 16, right? 1 over 4. So does this reach median? So your median is not in this interval. So when I come to here, when I put F4, what happened? 1 already, correct? So my median will be 4 on the interval 2 until 4. So therefore, 3 over 8m minus 1 over 2 must be accumulate up to 0.5 probability to find out the median value. So what is your m? Eight over 3. 8 over 3. Is it? In decimal is how much? Or 2 point something. So it must fall in this interval. We can't calculate the median then out from this interval. Then that is not the correct median that we want. 2 point something, right? Yes. So it is in the class, in the interval. So this is median value.